Get this going. All right, what you've got on the screen right now is what is referred to as engineering paper. And if you have been reading in your book, we're talking about engineering communications today, and we're going to start talking about engineering ethics. So I'm going to try to get to Blackboard here in just a second. But the idea behind engineering paper is it has kind of dark lines on the back so that you can do nice sketches. Alright, so we're getting there. Okay, not now. Get through here. We're still getting there. Big six. Yippee! That's weird. Alright, so just trying to get us through. So engineering paper, we're about to talk about it, but engineering paper's got on it some header pieces so that you can put names, document names. When we start talking about engineering drawings and talk about title blocks of engineering drawings and things like that, you will actually be able to see why these title blocks make sense. The other thing is it gives you a grid into it so that you can actually look at and be able to sketch problems with a little more accuracy than trying to freehand it. On the back, you do have the actual grid or graph paper. Now, most of the time, when we're writing on engineering paper, we're not necessarily using the back. You can use the back if you're doing like plot plans or sketches or those kinds of, just general graphing type stuff. You can use the back, but typically we don't necessarily do so. Typically we just write on the front side of the paper. Up in the corner is usually where people put the page numbers. So if I'm working a problem for an upper division class, you will have some engineering instructors that require you to use engineering paper when they are actually doing the documentation. But usually you'll put in like 1 of 1 or 1 of 2, and you actually have a page number associated with it, so people know, what page that you're working with, what page that are going on. Brandon, you've used engineering paper, haven't you?
Mm-hmm.
What do you think about it?
Well, it's great stuff. I like it. It's very convenient.
Yeah, so when you're working problems and you're actually drawing sketches, you're actually drawing graphs, you're actually drawing, doing a variety of different things, you use engineering paper. And you can buy it at the bookstore, both on the Enid campus and on the Tonkawa campus. And apparently last semester people loved it so much that it disappeared. And they actually have new thicker pads of it instead of the 50 pad pieces that are there.
It's required in Mr. Knoxon's.
Yeah, it's required in Dr. Knoxon's class.
Yeah.
So it's required in thermo. I don't require it. Couple of reasons is because when I do statics, we're doing a lot more online, and I actually prefer a different type of paper for 3D drawing, and it's not on engineering paper. And I'm not making you turn in paper homework assignments, is the other reason. So I don't require it. But it is very, very useful, and a lot of engineering instructors are going to require it. A lot of engineering firms have you work on engineering paper for where you're at. And it is handy. I mean, it's totally handy to have. So that's engineering paper. I'm going to switch over to the computer, and we're going to see how this goes. And hopefully the overhead projector will stay on the entire class. We've had fun with it of late. So we've got this. So over in our Intro to Engineering, what we've got here under course materials and assignments, we have opened up Week 6. We're going to be working in chapters 4 and 5. You've got in mind now Michael, are you around? Looks like Enid's pretty empty at the moment. everybody. That'll be interesting. So, so we've got this week's expectations. You've got in here, we're working chapters 4 and 5. They're in MindTap. I've got a link to an on-point discussion, and this actually happened last semester. So it's an NPR type program, and it was talking about during the World Climate Summit and talking about climate change and looking at standards, because that's one of the interesting things if we talk about engineering standards and codes. Climate change is kind of one of those things that's right now in the big picture of things, looking at that part of it. So one of your discussion items is relates to standards and codes. I'm going to go ahead and turn those down because we were getting lots of feedback from them. Okay. So as we are working with it, I've got a discussion board related to climate change and talking about standards, codes, international regulations, international agreements, those aspects, because it does affect every engineering discipline. It affects all engineering disciplines. Right now, one of the big debates that's going on with related to standards and codes is the National Environmental Protection Act. And under the Trump administration, there's a push to relax, and this is the critical part, and that's why there's a lot of debate. There's a push to relax NEPA, that's what it's called, N-E-P-A, to relax it a bit. Now, if you listen to one segment of the population, this is the most horriblest thing ever to relax NEPA. That is not how I understand what is being proposed. So before you do any big engineering job, you have to do an environmental assessment to find out if it's going to harm or hurt the environment. So if I'm putting a new road in, I'm putting a new industrial plant in, especially if it's in green space, which means it's not an area that's been developed. So let's say I'm going out here south of 412, between here and Enid, and I'm putting in a new windmill farm, which is something that's happening around here all the time. I'm going to have to do a NEPA review. If I want to put in a hemp or a CBD oil distillery in Osage County, in a green space, meaning that there isn't currently an industrial activity in that particular location, I'm going to have to do a NEPA activity. So the idea behind NEPA is, am I going to harm groundwater? Am I going to harm surface water? Am I going to increase air pollution? Am I going to threaten an endangered species? And around here in Oklahoma, one of the ones we have to worry about is the horned lizard, aka the horny toad. We have to worry about that one. By the way, they're on their way back, which is really cool. If you're further out in the panhandle, you have to worry about the lesser and the greater prairie chickens. And even the lesser and the greater prairie chickens do not like windmills because they will not cross the road. So we have things that we have to worry about. But what I'm hearing is the proposal is that if I am doing a major construction project or a major dam project or a major something that's really, really big versus something that's on a smaller scale, it can take up to 7 years to do a NEPA review. Well, I don't know about you guys, but if I'm a business opportunity and I am trying to get in and make a big, huge investment, I'm not sure I want to invest 7 years in order to get this investment to go through. And then that's not knowing whether or not it'll be approved or not. So the proposal, as I understand it, is to reduce that 7-year time. Not necessarily to reduce or lessen the restrictions, it's to speed up the process. And having dealt with NEPA reviews in the past, some of them can get pretty, pun intended, squirrely. For example, in Arizona, this was actually the Vatican. The Vatican wanted to install an observatory at the top of a mountain. And as part of that installation, they were buying up a great deal of property for that observatory because they wanted to do, if I have an observatory, I don't want to have light pollution. Okay, so I don't want to have light pollution, so they were going to buy up what we call green space, that space around the installation that you want to have. So they were going to buy this, essentially buy the whole mountain, to make sure that they had very little light pollution, and they were going to install a solar, or not a solar, okay, it went off. All right. So, is the fan, did anybody hear the fan running? Okay. All right.
It's red.
It's red, it's turned itself off. Guess we're gonna do this. We're having a technology. It's off. I'm gonna give it a couple seconds, I'm gonna let it go back, and I'm gonna turn it back on. And then at this point, I'm just gonna tick how many times it goes off.
Okay, I'll just go up there, try to work on it when I get out. How many classes are in
I honestly don't, let's see, in this room today, statistics, D. Cooper comes,
9,
yep, and there's one at 10:30.
10:30, so yeah, I'll just,
Yep.
Do you know if any of them are having issues with it?
I haven't talked to Dee about it, and I haven't talked to Kathy Ballard about it.
Okay, well, I'll try and get it all cleaned out with air and see if that makes a difference.
Okay?
If anything, if it does it again after I fool with it, I can put a different one in there and try to figure out what's wrong with that thing.
Yeah, because it's definitely the overhead projector. Everything else is working.
Right, okay, thank you.
Okay, all right, bye. Okay, I'm gonna do this. I'm gonna go to teaching camera, so you guys, so they should see me over there. I am not going to try to do a PowerPoint today. All right, so I'm gonna go to student camera first. This is fun. So we're gonna go receiving, there we go, teaching. Okay, so they can see me. So you guys can see me over in Enid? Okay, and you can see me, Tiffany?
Yes.
Okay, cool. All right. Okay, and we're gonna turn this back on.
Shut, that's not shut, it's not overheating.
It's, no, and apparently IT didn't believe me that it was doing it last last Tuesday. And he came in to make it do it, and of course it didn't, you know, IT person comes in, right? And it doesn't do it, right? So that's normal. Yeah, it's natch, right? And yesterday, it went out during engineering physics, and I had the last class in the classroom on Tuesdays, and when I came in this morning, the whole room was up, except for that. So it obviously was doing it again. And we're not going to actually use the overhead projector. We're going to leave it on me. But okay, you guys can see Enid, but we're going to see how many times it goes off. And we're going to time it. I've got that it's 8:15 that it went off, and see how long it takes it to shut off. So yeah, this is called troubleshooting. This is an engineering practice. It's called troubleshooting. And when you troubleshoot something, you try to recreate the conditions at which it goes bad. Except I think it's a bad fan on here. So anyway, so back to NEPA. So the Vatican was actually going in trying to do this. And so they do their NEPA review, and they find out on the top of this mountain in Arizona, there's the subspecies of a red squirrel. It's indigenous to the area. It's a subspecies of a red squirrel. And you know, certain organizations came after the Vatican to not put in the observatory because of the subspecies of red squirrel. Okay, I can get it. I can understand. I'm a person that's right up there with everything on the next person, moderation and all things. But if I'm gonna do a project on this mountain, I think an observatory where I'm going to not have a whole lot of people come in, I'm buying up a whole lot of green space, might not be a bad thing for a subspecies of red squirrel. But it killed the project. Totally killed the project. I can give you another example in southern Utah that the whole project was killed by a hole. Somebody, under their NEPA review, looked at this hole and swore that this hole was a black-footed ferret hole. Nobody'd seen black-footed ferrets in the area for 2 decades, but this empty hole was certainly a black-footed ferret hole. There were other ferrets in the area. How they knew it was a black-footed ferret hole versus another ferret hole, I don't know. But it killed a whole project. Totally killed the whole project. So, again, those are 2 examples where NEPA was taken to the extreme. There are other ones that you actually look at and you go, okay, yeah, we need to kill this project. This project shouldn't be in this area because of an environmental condition, or because of a wild river that's in the area, or because, so there's lots of times that NEPA reviews do the right thing and say, no, we shouldn't do that. We shouldn't have something go through the Yellowstone National Park. We shouldn't have something that goes right up to the edge of Yellowstone National Park. But we also shouldn't take it to the extreme of an empty hole or burrow hole is claimed to be something that it's not. And that's one of those situations that you have to really look at. So to me, if I'm a project and I've spent 7 years between biologists arguing over whether or not this empty hole that somebody saw, that's 5 miles away, by the way, of the intended project area, that, should that hold up a project, and should you spend millions of dollars to do a review just to have the project killed by a potential whim? And that's one of the things that people, the pro, let's modify the regulation, are saying we need to shorten the process. And that's one of the things that you end up dealing with. Having dealt with environmental regulations for 30 plus years, I can give you the pros and cons of both sides. Totally give you the pros and cons of both sides for a lot of regulations. When I drove through West Virginia in the 1970s, it was awful. Air pollution was terrible, dealing with the mines and the mining and the smokestacks and everything. You drive through West Virginia now, you don't even know there's mines there. If you go by the refineries in Los Angeles, if you drive by the Ponca City refinery on a hot day, you're going to smell the crude oil. Okay, you will smell the crude oil. I will tell you that the Los Angeles refineries, you don't smell a thing unless there's an upset. You don't smell anything. You see it, you know it's there, but you don't smell it at all. So there are good points to the regulation. Totally good points to the regulation. Our air is so much cleaner because of that regulation.
Have you ever seen Chinese skylines?
Oh, they're awful.
Yeah.
And that's because they don't have environmental or environmental, the same level of environmental regulations that we do.
I don't even think they have any.
Well, they have some.
Except around the Olympics.
Well, they have some. But, our water situation, our air situation, much, much different than what it was in the 70s. And a lot of that is a result of things like the Clean Water Act, Clean Air Act, the Toxic Substance Control Act. But there's a lot of pros and cons about everything. So I'm a moderation of everything type thing. So we do have a variety of different things on our regulations. So standards and codes are important. The question then becomes the scientific basis for those. And that's always an interesting piece. And that's another big debate that we currently have Yes, ma'am. Did you have a question? Tiffany, did you have a question? Okay, cool.
I was clearing my throat.
Just making sure. Just making sure. So we have a lot of things on our standards and codes. And there are a lot of things that make total sense. Where do they come from? Fire codes come from the fact that we've had horrible fires. Usually an accident is what's going to trigger a new code. Usually an accident is what's going to trigger a new regulation. When I started with Phillips Petroleum back in 1989, that's when I first came in, the day I did my thesis dissertation defense was the day the Exxon Valdez ran aground. And that's the day that we had the big oil spill in the Sound up in Alaska. 6 months later, I was on the phone with a colleague talking about some plastics and doing some plastics when we got word over the radio where he was, because he was actually located in Houston, was the K-resin explosion at the Houston Chemical Complex. Both of those events changed environmental regulation and changed business activities tremendously. And both of those, the actual root cause was a human error. Root cause of the Exxon Valdez was somebody wasn't paying attention. Although all bad accidents usually happen in threes. 3 things have to go wrong. One of which was the actual protections on the ship. The actual protections on the ship, that's why we have double hull tankers now, so that we don't have an Exxon Valdez, even if somebody has a human error. That's why we have redundance and alarm warnings, because it was a frozen valve that created a runaway reaction, which blew up the Houston Chemical Complex. So safety regulations, environmental regulations, they're all important, and I am a proponent of them. But I can also tell you that we have regulations that drive you insane. For example, if I comply with a regulation under the Clean Air Act, I can actually be in violation of a regulation under the Clean Water Act. If I comply with the regulation under the Clean Water Act, I can be in violation of a Clean Air Act or Clean Air Act regulation. I can point to you to a whole bunch of those types of examples. My other favorite, we were actually at the Borger Refinery, and we had an incident. It didn't hurt anybody. It wasn't particularly catastrophic, but it was one of those near miss type incidents. We had a valve that failed, and the reason the valve that failed, it had not been operated in quite some time. So because it hadn't been operated, nobody had known that corrosion was occurring in this particular valve, and it hadn't been looked at in a while because it wasn't a valve that was there for use during turnarounds, and so sometimes you don't do a turnaround for 5 years. So the valve failed, created a little bit of an air release, not much in terms of poundage, very, very small. But it happened to be on the flare line, which is the emergency relief valve for the flare. So the location of this valve wasn't the greatest for the situation. And as a result, the regulatory agency wanted us to put in a bypass around that particular valve, so you had one way or the other. So you could shut off one way or the other, and you could actually test the valve, and you could do that. Well, that would require that you put a person out there doing welding on a live pipe. So you would have to have somebody actually welding on a live pipe that contained hydrocarbon gases. So think about welding, right? Welding's hot, has sparks, hydrocarbon gas, that's gasoline vapors. You're going to have a person doing live welding. It was going to be a tricky operation. You would have to open the pipe to the atmosphere Again, because it was the relief valve, you weren't talking a great number of emissions, and you were going to, in order to put in the fix that was requested, you would emit 20 times the amount of the original release and put somebody in harm's way. Finally was able to talk the regulatory agency out of doing that. The solution was bigger than the actual initial problem. And you run into that a lot. We run into that a lot. We had a new regulation come in wanting to know, EPA felt like the refineries were under-reporting emissions. So they created this new tool that we were all supposed to use. And we kept telling EPA that the new tool didn't work. And the new tool didn't work. And we finally got the person who created the tool to, and it was a wastewater drain tool to calculate how many emissions you were getting from your wastewater. And we asked the person who created it if they could try to do a person's house on the tool. Turns out you couldn't even do your own house with your bathrooms and your kitchen sink on this tool. And they were trying to do that for a refinery that has thousands of drains. Finally got the guy to realize that his tool was broken. It's not that we didn't want to use the tool, it's just that the tool wasn't right. And I will tell you, it makes a huge difference. I worked out of an office in Houston and I supported 13 different refineries. And we had a refinery that was at a different place, and we looked at it on the engineering drawings. We looked at it on the engineering drawings, and they were trying to come up with a way to capture a relief gas that had been currently going to a relief valve that went to the atmosphere. And now granted, you don't want to have that happen, but it's an emergency valve, and we were trying to figure out a way to put it into the flare system so that it wasn't going to go to the atmosphere should it fail. And the guys kept telling me that the drawings indicated that it would be an easy fix. It would be like a 3-foot pipe run. And the guys kept telling me, no, that wasn't going to work. Kept telling me, no, it wasn't going to work. And I kept going, but the drawings are saying, and they said, no, it's not going to work. So I said, fine, I'll finally go out into the field. And I went out to make a trip. I had another whole lot of other reasons to go out there. And I said, okay, go show me this valve. And you go out and look at this valve and you go, oh, there's no way that's going to work. Putting eyes on a valve sometimes makes all the difference in the world. So you can't necessarily do stuff from your desk if you're doing engineering work. You have to go out in the field. And I spent most of my time out in the field. It was a lesson learned. That when we're having a debate, go out and physically look at it, because you're going to find out that there's something associated with it. So engineering drawings are a way of communicating. Engineering papers are a way of communicating. Standards and goals are out there. I was going to run a PowerPoint. Should I attempt a PowerPoint? Let's see if we can do that. Let's see if we can do it. We'll tempt it. We'll tempt fates. We'll tempt fates.
Whenever I was going to machine tool, the biggest complaint was that the engineers made all these blueprints that was like impractical. Because there would be like bolt holes where you can't even put a wrench and all this other.
Oh yeah. Well, the other one is I worked with a process unit that the person who designed the process unit did not think about the orientation of the actual vessel. And so the manway was put in between the two vessels, and the vessels are spaced 8 inches apart. So we had to flip the process unit or the vessel over and install it in backwards in order to make it work, because they did not do 3D thinking. So let's talk about a quote. This quote drove me crazy this morning. A particular Democratic candidate, I will not name names. Actually, what?
You can.
I will not name names, and I am not one way or the other on this one. But I am really offended by the quote, and I think other people will be offended by the quote. And I will tell you, most of my Facebook feed is offended by the quote. So I will highlight that. The person has indicated that anybody can be a farmer. All it takes to do farming today is that you go out, you dig a hole, you plant the seed, you put fertilizer on it, and the corn comes up. I don't know about you guys, but I can't even get that to work in my backyard garden, let alone if I'm trying to do thousands of acres in the Texas Panhandle. Or I'm trying to do acres here in Kay County or Osage County or Noble County or any of the Grant County. I'm sorry. Between the fertilizer regulations that I got to deal with, whether or not I can spray a pesticide. Oh, by the way, we can have to do no-till planting. Oh, by the way, we have to have certain margins of environmental regulations. Oh, by the way, you practically have to have a technology degree to operate the new combines. I'm sorry, not everybody can do that. So his claim was, we were an agricultural economy for 30,000 years. You can teach anybody to farm. Now, right now in the United States, less than 2% of the population is engaged in farming and supplies, not only us, but a lot of the world. I don't think we're just putting a seed in a hole and putting a little bit of fertilizer on it and picking the corn. Somehow, I don't think that's the case. He says, okay, then we became an industrial economy, and Brandon, you'll love this one. We can teach anybody to put a piece of metal on a lathe and crank it within the direction of the arrow and get a part.
It's actually pretty hard.
And I'm going, don't think so. Don't think so. So apparently we have a certain presidential candidate that is a little on the not part of reality side of things. And it'll be interesting. Like I said, my Facebook blew up like crazy because, of course, I have a lot of technical people that do technical trades, and I have a lot of farm people who do a lot of farming, and most farmers that I know of, unless you're on a big industrial farm and have a whole lot of money, they're doing another job in addition to farming in order to still be able to family farm. So it's kind of an interesting thing that's out there. And in fact, right now, you want to look at some really cool aspects of engineering. Look at agricultural engineering, biosystems engineering, a lot of those, because I actually looked at a soybean seed, which is kind of an interesting thing that if you come from the seed buyers to the soybean seed, you actually, if you go buy a soybean seed at Atwoods or TSC or someplace and you want to plant it in your backyard, it's like a little seed, and it looks like a little seed. But if you want to do it for an industrial farming operation, they're coated with fertilizers and they're coated with all kinds of other stuff in order to get that seed to have the best optimum growth. So even the technology that's going into the seeds that are being planted is huge. Totally huge. So when we're talking communications, I'm going to skip through this. I want to look over here. We've got examples of written communication. We had this discussion in my engineering physics class yesterday. How do you communicate your homework so that somebody knows what it is you're trying to do? Progress reports. You got to do progress reports when you're not only in any kind of engineering activity, any kind of business activity, you're doing progress reports. What did you do this week? Technical reports, we have lab reports, design project reports, memos reports, for a variety of things. So we have engineering problems. So I'm going to go through our engineering problems. I'm going to get through this part because we've been talking about these things already. So here are guides for homework presentation. You've got to have a problem statement. You've got to be able to communicate what it is you're working on. I used to carry a keychain that said a problem well stated is a problem half solved, and that is absolutely true. You've got to have your diagrams and things like that, and that gets us to our engineering paper. So if you're doing an engineering problem on engineering paper, this is typically how you're going to submit it. You've got your problem statement, you've got your work, you've got all of that aspect to it. So you can do that aspect. You don't necessarily have to get there. Be able to communicate your results so it's easy for the instructor to find. One of the reasons I do an awful lot of online homework is because I am tired of trying to find the answer. I am tired of trying to find the answer. I am tired of reading people's really ugly handwriting. I am tired of trying to follow the logical thought throughout. But as you go up in your engineering classes, your homework is like 2 problems, not multiple problems. So you've got to be able to communicate what it is you're working on and how that works. You've got to be able to do it. So I'm going to skip through that. We've been doing written communication. That's what the memo parts are. Oral presentations, I know you all hate it, but you're going to have to get up and speak. One of the all-time best engineering people I knew, back in the late 80s, early 90s, companies were laying people off about once every 2 years. And they were laying off their technical staffs. They were laying off a variety of things. One of the best process plant engineers I ever knew was laid off because upper management did not know him. When it came to lists of names that came in for layoffs, nobody could tell you what he did. Nobody could tell you, nobody could even put a face to the guy because he went out of his way never to make a presentation. He didn't do a safety minute. He didn't do anything. So nobody knew him from mid-level managers to upper managers at all. And when you're sitting there trying to figure out what was going on, nobody had a clue who he was, and so he became a name on a list and was laid off. One of the best process plant engineers I ever knew. And it's because he would not ever give a presentation. You've got to be able to get over that. You've got to be able to get over that. So we have to write progress reports, communicating where you are in a project, keeping your client informed of what's happening. And I want you all to think about when you hire somebody to do something. Whether it's hiring somebody to mow your lawn, hiring somebody to detail your car, if you're hiring a mechanic to upgrade your car, and you take it to the mechanic and you put your car in and they say, well, we might get to it next week, you kind of know where things want to stand. And if it's because he has ordered the part and the part's currently in China and we can't get anything out of China, that's one thing. Or if the part came in on Monday and he just hasn't gotten around to it, that's another thing. And so progress reports, we expect progress reports out of people we hire, and we're going to be the people that are being hired. So we need to keep things that are up, keep people informed of milestones, keep people informed of that. Executive summaries is because executives don't have time to read everything. So they need a short synopsis of what's happening. Most executive summaries are a page to 2 pages. This says short, now it depends on the report. Sometimes it's going to be a very lengthy report. But you will get there so you end up having it. Short memos, that's what we've been doing. We've been working on our short memos. Technical reports. When you get to my statics class and my engineering mechanics class, you will be writing technical reports to give you practice going forward for senior projects. They usually have a title, an abstract, what the objectives were, discussion of the results, what conclusions and recommendations, all those things that are out there. Abstracts, again, are shorts, objectives, so we can go through each one of those pieces. So this book gets you where we're at. References are highly important. Attributations are highly important. Because when we start talking about ethics next week, it's an ethical violation to take somebody else's work and take credit for somebody else's work. NOC has a code of academic ethics. We have lots of ethics pieces that are out there. So you want to, and interestingly enough, this one doesn't have it, but it's a new thing that's going out, and partially because of how fast the internet is moving, is if you give a URL as a reference, they are actually requesting and suggesting that you put the date accessed. Because if the URL is broken, part of it is just because the data's gone away. Or somebody has dropped the website. So even, so if there's a URL, you want to put date access so that you know that piece of information, or at least when that URL was accurate. And so that's something that we've actually started doing, and that I had never done that until in January. And one of the journals I'm working with starts doing the date access. So we got cover sheets. We talked about oral communication, but now I wanted to get examples of engineering drawings. For those of you who are here with me, we do have SolidWorks, and we can get you the SolidWorks if you want it. I have 65 student licenses for SolidWorks, so that you can do blow-ups, different types of engineering drawings, different types of things. And I think that gets us through before we gotta get out of here today. And I am not gonna fight my overhead projector. That has been on for 30 minutes now, so that's pretty cool. And we will come back and talk about ethics next week. You do have 2 discussion boards in there and 2 quizzes in MindTap. Questions? Alrighty. We let you go today.